Hi, well now that we've been drawing these Lewis structures and you know all about the octet rule, we're going to learn some exceptions to the octet rule. Now these exceptions are for the honors chemistry students only. The standard chemistry students are not responsible for this material, but go ahead and watch it. All right, now there are exceptions, and the first exception we're going to talk about is when you have less than an octet. Now we know that hydrogen only wants 2, and that makes it stable. So that's definitely less than an octet. But boron and beryllium also are quite content with only having 3 electrons in their outer shell, or then when it combines with something, having a total of 6. So boron and beryllium are quite happy with less than an octet. So here's an example. So boron has 3 valence electrons. It's in the same family as aluminum. As a matter of fact, it's above aluminum. It's and then it is combining here with fluorine that has 7 valence electrons. And this boron does not need a lone pair of electrons. This is the Lewis structure. So boron has 3 valence electrons, fluorine has 7, and there are 3 of them for a total of 24 valence electrons. And if we count this up, we now have 24 without a lone pair on that boron. So beryllium does the same thing. They're quite happy with just seeing a total of 6 valence electrons in their outer shell. The geometry of this, with 3 bonding pairs like this and no non-bonding pairs, the geometry is trigonal planar. It all falls into one plane. So whenever you're drawing a Lewis structure, if you have boron and beryllium, be thinking, oh, that's an exception to the octet rule. It will probably only have 6 valence electrons in its outer shell. All right, more than an octet. This is a lot more common. Central atoms that are in n is equal to 3 or higher can have expanded octets. So let's go ahead and look at our periodic table. So things in the first or second period, they cannot break the octet rule. There's just no room for those extra electrons to go. So if your central atom is carbon, it will not break the octet rule. Neither will nitrogen or oxygen or fluorine. These do not break the octet rule. But when we come down here, phosphorus and sulfur and chlorine, these guys are now in period 3, and they can accommodate an expanded octet. So if phosphorus is your central atom, it possibly could have an expanded octet. It doesn't mean it has to, but it could, and so could sulfur. And anything below them as well, like iodine can have expanded octets and so forth. So let's go and see what this looks like. When you start using those rules, like how many valence electrons do I have, how many do I need, it's not going to work. You're going to find out that you don't have enough shared pairs to hook up all your atoms. And so what you do is you just draw the Lewis structure, knowing now that this is an exception to the octet rule and that central atom may have more than an octet. And just make sure you represent all your electrons. Okay, so here we go. Let's go ahead and draw PCl5. We're going to pretend like we don't know it's an expanded octet. All right, so phosphorus has 5 valence electrons. Chlorine has 5, we have 5 chlorines, and each chlorine has 7 valence electrons. For a grand total, we have 40 electrons. Phosphorus would love 8, and so would all 5 of those chlorines. And so that brings us to 48. If everything had an octet, well, we see here that we would have 4 shared pairs. So we put phosphorus in the middle, and then we're going to put 5 chlorines just kind of evenly spaced around here. And we see that 4 shared pairs is not going to be enough to link all those chlorines to the phosphorus. So more than an octet around our central atom. So we're just going to go ahead and just start drawing. You got to connect every single one atom to the central atom, and then give all the terminal atoms an octet. So every one of these chlorines was only seeing 2 valence electrons, and now we're giving it a total of 8. All right, now let's go ahead and count up how many electrons we have represented here. We have 40 electrons, we're done. So this is 8, 8, 8, 8, 8. 8 times 5 is 40. That's how many valence electrons we have, and that is indeed the structure. We are going to build this molecule in class tomorrow and learn about its geometry and its polarity. Okay, let's go back and draw SF4. All right, sulfur is in the same family as oxygen. It has 6 valence electrons. Fluorine has 7, and we have 4 of them. So we have a grand total of 34 valence electrons. Every atom, the sulfur would like 8, and the 4 fluorines would like 8. And so that gives us a total of 40. Okay, this is what we would want. All right, so how many valence electrons would have to be shared? And the answer is 6 valence electrons or 3 shared pairs. So draw your skeleton, your sulfur, and then we're going to draw the 4 fluorines in. And wait. We cannot connect 4 fluorines to a sulfur with only 3 shared pairs. What does that mean? That means that this sulfur, and it is one of those elements that's in period 3 or higher, it is going to have an expanded octet. So we're just going to start drawing. Let's connect all of our fluorines to the sulfur, and then give all of those fluorines an octet. And now we're just going to make sure that we have represented here a total of how many electrons we have, which is 34. Let's count these up. That is 8, 8, 8, 8. That's 32. We're supposed to have 34. So those extra 2 electrons go right on that central atom. All right, so that central atom has an expanded octet. It has 4 fluorines bonded to it and a lone electron pair. All right, let's go ahead and do the next one, I3 minus 1. Okay, we have iodine. It has 7 valence electrons times 3. That negative charge gives us plus 1 more electron. We have 22 electrons to accommodate. Every iodine would love to have 8 valence electrons, so that's 24. When we take the difference, it's 1 shared pair. We can't hook 3 iodines together with 1 shared pair. That means that our central iodine is going to be breaking the octet rule. So draw your skeleton, give your terminal atoms their octet, and there we go. And then let's count and see what we got. Okay, we've got 8 and 8. We have 16, but we want to have 22. Put the remaining electrons on the central atom. Okay, that's 16, 17, 18, 19, 20, 21, 22. There we go. Now it had a -1 charge, so things that have charges, put in brackets and put the charge outside the bracket. All right, let's go ahead and draw SF6. We know this is going to break the octet. We have 6 things to hook to the sulfur. So let's just see how many valence electrons we have. Sulfur has 6, fluorine has 7, so 48 valence electrons is what we have to work with. So we're going to follow the Vesper model and try to distribute these fluorines as far apart from one another as possible. You gotta hook them to the central atom. Boy, that sulfur sure is full right now. And let's give every single fluorine an octet. Now you may want to pause the video if you're not able to draw as fast as I'm drawing. You want good drawings for class tomorrow, so when we make our models, we'll have these nice drawings. All right, let's count and let's make sure we have 48. 8, 16, 24, 28, no, I'm sorry. Let's see, 8, 16, 24, 32, 40, and 48. There we have it. All right, now let's go ahead. We've got 2 more to go. ClF3. They're both halogens, so 4 times 7 equals 28 valence electrons. Let's go ahead and put our chlorine in the center and distribute our fluorines. Give your terminal atom an octet and then count them. All right, the electrons that I have here would be 8, 8, and 8. I have 24, I need 28. 24, 25, 26, 27, 28. So extra electrons go in our central atom. All right, now our last one is xenon tetrafluoride. Xenon has 8 valence electrons. Fluorine has 7 times 4. 8 times 8 plus 28 is 36 valence electrons. Here we go. This is going to break the octet rule. We're going to distribute our fluorines. We're going to hook them all to the xenon. And we're going to give those terminal fluorines their octet. So we have 8, 16, 24. We have 32 electrons represented. 32, 33, 34, 35, and 36. Well, there we have it. We have broken the octet rule. Bring these drawings to class. We're going to build a model, and then we're going to talk about the polarity of these molecules. That's it. Have a great night.